All right, let's dive in. Today, we're talking about something huge, the architecture of our autonomous future. We're going to break down the research that connects three, you could say, pivotal companies. You've got the chip maker, the car company, and yeah, the flying taxi startup. Let's get into it. I know, this looks like something straight out of a sci-fi movie, right? But the thing is, this future, it's being built as we speak. We're looking at a world that's basically powered by this incredible convergence of artificial intelligence, super high-performance chips, and a total revolution in how we get around. So, what we're going to do is explore exactly how these pieces are snapping together to create something, well, something entirely new. Okay, before we really get into the weeds, just a quick but really important heads up. Everything we're talking about today is based on publicly available research, and it's really for informational and entertainment purposes only. So to be super clear, this is not financial advice, okay? Awesome. Now let's get to the good stuff. Okay, so the one big idea you need to wrap your head around for all of this to make sense is physical AI. You know, for so long, AI has just lived inside computers, right? On servers, in the cloud. It's all been digital. But what's happening right now is this massive shift. We're moving to what's called embodied AI. This is AI that has a body. It can see, it can move, and it can actually do things in the real world. Honestly, this is the glue that holds everything we're about to talk about together. So a revolution this big needs a power source, right? An engine. And that brings us to our first major player, Nvidia. Now, try not to think of them as just a chip company. It's much bigger than that. Think of them more like the utility company, the ones building the power grid for this entire physical AI world. And you don't have to take my word for it. NVIDIA's own CEO, Jensen Huang, really puts the sheer scale of this into perspective. Listen to what he's saying. He's not just talking about a new market. He's talking about a global infrastructure project. I mean, this is on a scale that we have rarely, if ever, seen before. And yeah, the numbers are just wild. Some research projects that the yearly spending on global AI infrastructure, it could jump by 566%. We're talking about a path towards trillions of dollars. And at the heart of all that spending, you're going to find NVIDIA's hardware. It's pretty much the indispensable engine making all of this growth possible. So you have to ask, how did they become so absolutely critical? Well, it really comes down to this incredible three-part competitive moat they've built. First off, their market share is just staggering. We're talking over 90% in the data center. Second, and this is maybe even more important, is their CUDA software platform. This is not just a piece of software. It's an entire ecosystem that they've been building for more than a decade. It basically locks in developers, and it makes it ridiculously hard for anyone else to even try to catch up. And number three, they aren't just selling shovels in a gold rush, they're actively investing in the miners. They have deep partnerships with the very companies building the future on their tech. Okay, so we've got the engine, right? The raw computational power. Now, let's talk about how all that intelligence actually gets put into motion. And that, of course, brings us to Tesla. They're the ones taking this physical AI concept out of the data center and putting it on our streets. So what you're seeing here is the absolute core of Tesla's advantage. And trust me, it's not just about making cool electric cars. It's all about this AI flywheel effect. Think about it. Every single Tesla on the road is a data-gathering robot on wheels. They're collecting unbelievable amounts of real-world driving data. We're talking billions and billions of miles. All that data gets fed back to train the neural nets. The AI gets smarter. And then, and this is the magic part, they push that improved software back out to the entire fleet, over the air. It creates this incredible continuous learning loop that nobody else can really match. The system literally gets smarter with every single mile driven by every single car. But here's the kicker. The vision is so much bigger than just cars. Elon Musk couldn't be more clear about this. He fully expects that the long-term value of the company won't be in cars. It'll be in general-purpose humanoid robots. And the Optimus robot? It's being designed to run on the exact same AI that's learning to drive their cars. The same brain, just a different body. And let's be clear, the goal here isn't to build the cheapest robot on the block. When you look at the research, you see a real contrast between what Optimus is aiming for and some of the lower-cost competitors. The focus is squarely on true capability. This isn't about a gimmick that can wave hello. The goal is a robot with the smarts and the physical dexterity to do real, continuous work in the real world. A robot that could eventually match or maybe even blow past human performance for a whole lot of tasks. Okay, so we've covered the computing power, we've covered the ground. So where do we go next? Up. Let's talk about our third pillar, which is taking this whole concept into the third dimension. We're talking about Archer Aviation and their mission to completely bypass urban traffic by going over it. So what you're looking at here is Archer's flagship aircraft. It's called Midnight. Now, the key thing to notice about the design is something called distributed electric propulsion. See, instead of one giant, loud rotor like a helicopter, it has 12 much smaller, independent electric motors. Why does that matter? Redundancy. It is all about safety. If one motor or even a couple were to fail, the aircraft can still fly safely, and that is absolutely crucial for getting certified to fly passengers. And when you look at the performance specs, you can see this thing is purpose-built for being an urban air taxi. I mean, it's fast, 150 miles an hour. It is incredibly quiet. We're talking about 100 times quieter than a helicopter, so your neighbors won't hate you. It can carry 4 passengers plus a pilot. And critically, it can be turned around for its next flight in just about 10 minutes. That's absolutely essential if you want to run a profitable, high-volume service. Okay, so let's zoom out and put all these pieces together. You have the computational engine from Nvidia, you have autonomy on the ground with Tesla, and you have autonomy in the air with Archer. So what's the end game here? What is the actual size of the prize that these companies are all chasing? Well, according to some research from firms like ARK Invest, for instance, the projected annual revenue, let that sink in, for autonomous taxi networks combining both ground and air could be somewhere in the ballpark of $8 to $10 trillion. That's trillion with a T. And that's within the next decade or so. It's a number so big it's hard to even comprehend. It doesn't just change the transportation industry, it completely reframes it. But a vision this massive, a number that big, it's never going to be a straight line to get there, right? So what's the catch? What are the big hurdles standing in the way of this autonomous future actually happening? It really boils down to 3 massive challenges. First, you've got the regulators. Getting brand new types of vehicles, especially ones that fly themselves, approved by agencies like the FAA, that is a long, expensive, and incredibly complicated process. Second is what Elon Musk famously calls production hell. It's one thing to build a cool prototype. It's another thing entirely to manufacture complex hardware at scale, reliably and affordably. It is brutally difficult. And last but not least, software stability. When they're putting an AI in control of a vehicle with people inside, that software has to be beyond reliable. It has to be rock solid, period. So if there's one big thing to take away from all this, it's this. You can't really think of these as separate companies and separate industries anymore. The research really points to a fundamental convergence. The old boundaries between hardware, software, and the basic infrastructure that powers it all, they're basically dissolving right before our eyes. And that kind of leaves us with one final, pretty big question to chew on. If this vision, this deeply integrated vision of physical AI actually comes true, if we have autonomous systems on our roads, working in our factories, and flying through our skies, what does our world even look like then? That right there is the multi-trillion-dollar question that's probably going to define the next decade and maybe a whole lot more.